first like to start by thanking Nora for inviting me to present at this conference. I'm glad Roddy got to speak first because he talked about the testing effect and how practicing retrieval from memory can really be helpful in learning. So today I'm going to be describing to you a study that involves looking at repeated retrieval practice, right? If you have many opportunities to practice retrieval, how should you space out those opportunities? First, I'd like to acknowledge funding sources, right? So this was research done when I was a postdoc at UC San Diego with Hal Pashler, and my other collaborators on this project are Mike Moser, a computer science professor at University of Colorado, and his grad student, Rob Lindsay. Right, so first I'm going to give you some background on what the spacing effect is, right? That basically describes a phenomenon whereby if you're going to review some information, as in re-expose your information that you studied earlier on, these reviews are more effective when they are distributed or spaced out over time rather than sort of massed or bunched together. And this is even when the total time spent on studying or reviewing the information is equated across both conditions. And this is really a very robust phenomenon in the memory literature, right? It's been observed with a diverse range of materials or different types of learning. And this effect is really not new, right? Ebbinghaus, sort of the father of experimental research in human memory, way back in 1885, observed when he was trying to learn these lists of materials, Ebbinghaus observed that with any considerable number of repetitions, a suitable distribution of them over a space of time is decidedly more advantageous than the massing of them at a single time. Right? So this was his observation way back in 1885. And we want to study the spacing effect. So the most basic type of structure you'd have for an experiment looking at this effect would be what's represented in this diagram here. So in the top row, that represents the mass condition, right? You would have this initial study, initial exposure to the material that you want the person to learn. Then there's this gap in time, you might call that the interstudy interval. And then you have a review session, some review opportunity where you re-expose the person to the same material. Then there's another gap in time, we call that the retention interval. And then we administer the final test to see how much of that information was retained, right? So that's the spaced condition. And in the bottom row, it's almost the same events there, that's the mass condition. So the only difference now is that there is a much smaller gap or no gap between the initial study, the initial exposure to the material, and that review opportunity. Right? And when I say that, when I use the term review here, it's just a generic label. It can mean restudying of the material, it can mean practicing retrieval, testing the person and giving them feedback. So that's with one review opportunity. Right? What if there are multiple opportunities to review the material? How might you space out those various retrieval opportunities or practice opportunities? And so an idea arose in the literature that said, well, spacing is good, but there are multiple ways to space things out, right? You could space things out in an expanding schedule or in an equal interval schedule. Right, so to explain what that means, if you look at the one that's labeled expanded retrieval, that's the expanding schedule, right? So you have an initial encounter with the material, then there is one gap for one intervening item, and then you have a review opportunity, a retrieval attempt of that original item, then it expands, there's now 3 intervening items, and then you have to retrieve that original item again, and then it further expands 8 items, and then you retrieve that initial item again. So that's the expanding retrieval, right, as described by the label, the term. And so below that, that's the equal interval condition. You might get initial study of the information, then there are 4 intervening items, then you might restudy or review that information, original information, and 4 intervening items, review the information, and so on. So that's equal interval or uniform interval practice. To put this in more concrete terms, right, so you're here at the conference, you're probably meeting many new people for the first time, you're trying to learn people's names, it's kind of embarrassing you have to keep sort of looking at people's name tags when you see them again and again, so perhaps you want to practice retrieval, right? So imagine you introduced a person by the name of Alison Shaw, she tells you a name and you meet her for the first time, and then if you want to practice a name in an equal interval fashion, you might then talk to 2 other people, and then you turn back to Alison Shaw, you try to retrieve a name, then you turn to 2 other people, talk to them, then turn back to Alison Shaw, you try to retrieve a name, so on. Right? So that's equal interval practice. And then below that's the expanding practice. You meet Alison Shaw for the first time, you might then turn to one other person, and then you turn back to Alison Shaw, you try to retrieve a name, then you meet 2 other people, turn back to Alison Shaw, then you meet 3 other people, and then you turn back to Alison Shaw again, right? So the important thing to note is that across these 2 conditions, the average spacing is the same, right? It's basically 2, right? The only difference is when those practice opportunities are sort of scheduled, when they are placed, right? The distribution of those practice opportunities is different across the 2 conditions. And this idea of expanding versus equal interval practice first arose in the memory literature from a book chapter written by Tom Landau and Bob Bjork in 1978, where they argued that an expanding sequence of practice was advantageous, right? And in support of this claim, they presented data from an experiment where they gave subjects first name, last name pairs to learn, right? And as you can see in the expanding condition in parentheses, here is the number of intervening items between each successive retrieval opportunity or retrieval attempt, right? So 1, 4, 8 is an expanding sequence, and then the equal interval condition was 5, 5, 5. And what I want to draw your attention to is the final recall at the right-hand side of that table. Right, this was administered 30 minutes later after they were trained on these first name, last name pairs. And what you see is that in the expanding condition, recall performance was better. They learned the names better. There was 45% versus 40. Right? And so they say, aha, this is evidence that expanding retrieval is superior to equal interval practice. And the explanation was very intuitive, right? With expanding retrieval, it fosters successful retrieval at longer, progressively longer and longer intervals, right? So what you want to do is have that first retrieval attempt occur soon after study. By doing so, you ensure a high level of success, and as we've talked about before, right, testing yourself, being able to retrieve the information successfully, helps strengthen the information, makes it less more resistant to forgetting, right? So that's good, having retrieval success by having that first retrieval attempt occur soon after studying, and then the memory is strengthened. Now you can push the subsequent retrieval attempts farther and farther out in time, right? So that's sort of the logic behind the expanding practice. And so this is very intuitive. It's been incorporated in cognitive rehabilitation techniques used with older adults, with people with a mild cognitive impairment, and so on. So a very attractive idea, very intuitive. Well, unfortunately, perhaps, more recent studies actually failed to find this advantage of expanding over equal interval retrieval practice, right? So this is just a list that are more. This is just a selection of some of these studies that failed to actually replicate this advantage of expanding over equal interval practice. So much so that in 2007 there was a book chapter that reviewed this literature, right, done by Dave Bellota and colleagues, and they tried to answer this question: is expanded retrieval practice a superior form of spaced retrieval, right? So that was the purpose of this review chapter. And you can see this quote from their paper, right? They say, the results of the current review lead us to conclude that, as expected, spaced practice produces considerable benefits in learning compared to massed practice, right? So that's not up for contention, right? The idea that spaced practice gives you robust benefits over mass practice, that part is, not up for debate, right? But this is the part that highlighted in red. They say, however, the additional benefits of expanded practice over equal interval practice have not been well substantiated in recent research, right? So this was their conclusion in 2007 based on all these new studies that were coming about. So should we then say, well, the case is closed, right? Well, my colleagues and I, in reviewing this literature, sort of detected some, what we thought were kind of serious limitations, right? So what are some of these limitations of this prior research? Well, one, right, spacing was almost always manipulated within a single learning session, right? So in those examples I described to you, learning Alison Shaw's name and so on, spacing was operationalized in terms of the number of intervening items within that one learning or one training session, right? So that's a limitation, and I'll tell you why. And then the second limitation is that in all these prior studies, that there was almost always this exclusive focus on final test performance, right? So they would look at performance after some specified retention interval and see how much of the learning was retained, and that was used to decide which type of practice was superior. Those are limitations because, again, if you're interested in sort of applying this in sort of more real-world types of situations, if you think of everyday practice, it's probably more realistic to think of review sessions occurring across separate days, right? How often do you find students, let's say, reading a textbook chapter and then rereading the textbook chapter again and again and again within a single review session? Probably not too often, but it might be more realistic to think of a good student, a motivated student, reading that textbook chapter on one day, and then maybe after the class, relevant class, they might review that chapter again, and then maybe before the exam, they might review that same chapter again, right? So the practice is across separate days. And also, what if the aim is not so much to optimize performance on that single specified time point in the future, the final test, but rather, what if the aim is to acquire as much of the information as possible, and to maintain as much of that information over a considerable length of time, right? What if that's the aim? And you might say, well, what are the situations in which that would apply? Well, you can think of on-the-job training, right? Think of medical training, right? The hope is that when medical students try to learn all this these copious amounts of facts that they have to learn, they're not just learning it so they can pass their board exams, right? Hopefully, they're acquiring as much of this information as they can and maintaining as much of the information over time, at least during the time they're practicing as physicians, right? So we decided to do a study that we thought better captured sort of these types of conditions in the real world. And so we compared these two types of practice, expanding practice versus equal interval practice. And the way we operationalized expanding and equal interval practice was practice on separate days, right? So in an expanding condition, practice was on day 1, 3, 9, and 28. And so the numbers in parentheses here are the numbers of days that separated each review session. And then in the equal interval condition, practice was on day 1, 10, 19, and 28, right? So this training basically was spread out across a 4-week period. And the study stimuli in this study were 60 Japanese English word pairs. So this is sort of foreign vocabulary learning, and I'll argue later on that this would probably apply to many types of sort of basic foundational learning as well. And so what happened? Well, on day 1, right, items were presented initially for study, right, 8 seconds each, and then this was then followed by 3 cycles of test study. And what I mean by test study is that for 6 seconds, the Japanese word would appear on the screen, and during that time, the subject was told to try to recall, to type in the English equivalent if they could, and then this was followed by 2 seconds of feedback, right, the Japanese word and the English word appearing together. So you can think of this as studying with feedback. So this occurred for 3 cycles on day 1. And then on the subsequent review days, right, days 3, 9, 10, 28, and so on, there were again 3 cycles of test study. And then we also decided to build in this final test on day 84. So this was 12 weeks after the initial study, right? We wanted to have this test to see how much they retained, 12 weeks later. And so let's take a look at the results. And so this is during the training phase, the 4-week, 28-day training phase, right? And so you can, if you recall, I mentioned there were 3 test cycles, so that's what T1, T2, and T3 refer to, right? They were tested, they got to study the item again, right? Testing with feedback, so as you would expect, performance does improve after each test cycle. So that's why you see T2 is higher than T1, T3 is higher than T2, right? And also, if you're just looking at this kind of cartoonish type of drawing, and I'll tell you why it's a bit cartoonish, is that the area under the red curve, or the red graph, the red lines, seems to be greater than the area under the blue lines, right? So again, remember I mentioned earlier on, what if the aim is not so much to maximize performance on that final test, but rather to promote rapid acquisition and also as much of that, and also maximize maintenance of that information during a considerable period of time, right? So in order to measure that, we would want to look at area under the curve. How much of the information remains accessible during this extensive training period, right? And in order to sort of answer that question in a quantitative way, right, my colleagues decided to do some basic math modeling of the data. Right, as I mentioned earlier on, what you saw was kind of cartoonish because we know that forgetting does not proceed in straight lines, right, as you saw in the previous diagram. Rather, there's lots of evidence that forgetting tends to follow this sort of generalized power law function, and so we did some modeling of that, right, so you see these types of curves, forgetting curves. And the other thing that we estimated as well for each individual subject is where learning would be after T3, right? So don't forget there were 3 cycles of test study. So after they were tested the 3rd time on each practice session, they got to study the item again, so that means their learning should have also improved a little beyond T3, right? So that we modeled for that as well. And once we did that for each individual subject, now we could actually sort of get the integral, or the area under the curve, and find a quantitative estimate of how much of that information was accessible during this 28-day period. And what we found was the expanding condition, there was on average across all these subjects, about 49% was accessible during the 28-day period, whereas in the equal interval condition, it was only 41%. So we see this significant advantage of having more of the information accessible if practice proceeds in this expanding sequence. And as I mentioned, there was also this final test that occurred on day 84, right, way out there, 12 weeks later. And what we find is that's actually a numerical advantage in the expanding condition, right? It was not statistically significant, the difference between the expanding and equal interval condition on day 84. But if we look at the amount of forgetting, Right? If we look back to day 28 and compare that to day 84, that interaction is actually significant, and so that means that there's actually slower, less forgetting in the expanding condition. So let me wrap up some conclusions. Right? So if you're going to review information across over a lengthy period of time across separate days, it's probably better to schedule these review sessions over expanding intervals. Right? Because such an expanding schedule seems to promote not only quicker acquisition of the information, but also allows more of that information to be accessible over the learning period. In addition, as I mentioned earlier on, right, this expanding schedule seems to retard forgetting after a long delay. And so you might say, well, what are the implications for schools? Well, right, these results, I think, do have implications in terms of training and practice regimens for even middle school science, where I think there's any subject actually, that there's a need to acquire some sort of foundational knowledge. If you're thinking of elementary school arithmetic, learning your arithmetic facts would be very important for sort of skill math performance later on. And also, in terms of spacing out practice, it also suggests to us a potential manipulation to sort of arrest the summer brain drain that many educators lament, right? The idea that with this 3-month-long summer vacation, many students, when they come back in the fall, they seem to have forgotten most of what they learned in the previous year, right? So perhaps having this well-placed practice opportunity during the summer might actually help arrest some of that drain, forgetting. And that's it.